Good morning to everyone. The end of the week. It's Thursday, and we're on a rainy day. And so summer is gone. We had a beautiful summer for a couple of weeks, and now we're into gloom and rain, and we need the water. So we're into formulas. That's good. What were we listening to, Jonathan? It was Imagine, John Lennon, but what was the last cut? Okay, how do you do the formulas? How do you do the work? Okay, and there's certainly questions. Now, just to put things in perspective from the standpoint of when you're doing work, and keep in mind we do have to start here within 2 minutes of the hour for our taping. And so you're cutting it really tight, and so you want to try to maybe cut back. I may have to make the cutoff at 5 minutes till 10, so you aren't working until 10, so we can get going. And I understand you had a little bit of trouble with the pyramid. I'm not going to talk about that right at the moment, but in terms of the formulas, other than the pyramid problem, which was the last one, did everything else go reasonably well? Yes. Okay, and we're getting done in terms of the amount of time. Are we pretty well caught up at this point? That's my concern. Okay, I had two comments. Michael, start with you.
Number 9 was a gate problem. Yeah. And
number 9 was a what?
A gate problem about a
fence, yeah, perimeter.
Okay, just a moment. Number 9. On the computer. Okay, because the one I'm looking at here in number 9 is just a rectangle. Okay, and James, that was your question also? And you realize you can print those out, but Marisol says she has it written down. Now, did you bring it with you this time? Yes. Okay, so we not only wrote it down, we brought it with us. This is an improvement. Okay, do you want to share? But do you have the problem you could share with me, what it says? Or you and James work together on it? Can you tell me who's going to explain what's there? Okay, we're going to have special delivery coming up here. Hold on. Let's see what Marisol has written down. And this is the one off the computer. Yes. Now, not everybody had the same problem.
It's the same shape. It's just different numbers.
Okay, and it's not like the 9 that I have here, which is the rectangle. No. Okay. So I'm going to try to draw a shape that looks a little bit like a lampshade. Is that right? Yes. Okay. Well, the one I'm looking at is like a lampshade, and some of you are talking about parallelograms.
It's like a gate in perspective.
A gate in perspective.
A lampshade on its side.
Yeah, a lampshade on its side. And you call that a gate in perspective. Okay. Let me see if I can draw what I think you're saying to me. Something like this. And I don't know if the sides are such that these are parallel. Okay, but this one certainly wouldn't be a parallelogram, and so it's going to depend on which one you did. Now, this is a 4-sided figure, and if it were this or it were a parallelogram and you're asked to get perimeter, did they give, and they say in this particular case it was a 10-foot gate, and so you had some measurements given on it. Now, I'm seeing a 380, I think, in what Marisol has. Yeah, and then we have a 300 and I think it looks like a 360 in the top from what you wrote. But that could change with each problem. And then here, what is written down is 180 feet. And then on this side, I guess there's a gate here. So there's a gate in the fence. So this is, the gate itself is 10 feet. And you don't know what this distance is? That's 140. 140. Okay, now, what? I mean, that's what I'm seeing on this one, and it may change depending on the problem. So can we sort of pass this back? Well, the question is, I don't have the question from the problem. Am I to include the gate, or is that an opening in the fence? James, I'll start with you since you have Marisol's paper there in front of you now. Yeah. Oh, this is the cost of the fence. $5 per foot for the fence. Okay, I'm going to go to Larita now. Larita.
When you get the perimeter, you subtract the 10 foot gate.
You had a gate you provided separately. Okay. Okay. So the idea is the material fee. Material fee, $5 per foot. The gate it's separate is $85. A prefabbed gate. So $85 for the gate, which we then, in terms of what we have, we need then to add the entire 4 numbers, subtract off the 10, that sum would be multiplied by 5, and then add in the 85. Are we agreed on that? Or an agreement? Michael.
So my whole problem was it didn't specify whether you were supposed to, it didn't really mention like what the gate was doing. I mean, it didn't tell you that.
Okay.
Look at the example in order to figure it out.
Okay, so the concern is the problem was not quite specific enough to indicate whether the gate would be out of the same material. Or was a separate entity, prefabbed or something. And I guess if you looked at the example, problem 46, okay, going to that. And Jonathan, are you trying to bring up the mics when people are speaking right into them? Okay, well, when Michael's right in front of it, I think you probably could. But if we come here to number 46, okay, this is a little bit different than the diagram and the problem that was indicated, because this was a problem as we go to the document cam now, where I have 2 gates and a house sort of, you've all seen yards like this. And so the gates are different material, and in this particular case, it's $50 each for 4-foot wide gates, and so you're right, it's a very similar problem. And there are times when the information may not be as exact as you want, and you sort of work your way through it and you talk about it. And I hope that there are a couple of you together where you could discuss it. And it's a very practical problem in terms of materials. Do we need to go further in terms of the strategy? We know what to do with that one? Yep. Okay. And we didn't have problems entering our answers into the computer homework this time. Very good. So, yes?
Okay, I got that and then I put in the right answer and finally it was wrong.
Okay, so you did have a case where you put in an answer. Now, if they wanted it in terms of dollars, did they expect a dollar sign with it? Okay, so you just had to put in a number. And you put in your number, and it wouldn't accept it. So, okay. So that's one of those glitches, and the only thing that comes to my mind is it's something with the form of the answer in terms of that the dollar sign was there. Did you have to put a .00 after it or something like that? No? It was just misbehaving for you. Okay, I don't have anything other to say than call and see if you can get your cup of coffee. That's the best I can say at the moment. And they should be fewer glitches as we go along, I'm hoping. But if we have it down to 1 glitch out of all of you today, that's an improvement. Okay? Now, I think the biggest concern here is the time frame available for you to be doing the problems. And so what is an alternative to that? And let me just give it to you. You can go to the problem set and print it out, as would be done on the computer. Otherwise, the ones assigned to you. Then you can do those, come back and just enter your problems. So you could be doing them at home, come back and just enter them into the computer. So that would be a case where you would be in a lab and you print out. Unfortunately, I don't know how many pages of printout that would be, and it might get a
10
bit...
pages for that particular
10?
day.
And what is it per page?
10 cents.
So that'd be $1 you'd be paying for paper just to get a printout, which may not be feasible if you don't have the $1 to put in at that point. That would be something, let me talk with Brian on that to see if there's some way that we could get as part of the support mechanism. So you could print out with the print card, but not have to have it come out of your pocket, so you could do things ahead of time. Otherwise you print it out, go home with it, come back, and then enter. Okay, the Trio Lab, you could do that? Okay, that might be the way of doing it if you have a long assignment. And this was on the long side, but not as long as the next one. Now, when you have word problems, they do take time. And if you had a limited amount of time, like you only have 1 hour, then you may not get to the end. And what I'm trying to push a little bit more right now is that you work towards those deadlines. Okay, so I'd like to see where things are, and I need to look at how you did, how things are going, whether I open this one back up or not. But right now I want to go on to the new material rather than open that back up. I will answer a little bit more on this set of problems. So, Dion, you have a question?
Oh, well, no, it's not related to the problem discussion. I wanted to ask it on the test. Are we going to be able to redo it?
Okay, on the testing, the test I give will not be in the computer. The test I give will be an in-class situation, and we won't have retests on those 3 exams I give or the final. The first one was a quiz. Okay, quiz as opposed to a test. Okay, I understand what you're asking then. On the quizzes, as it stands right now, I'm going to take those as they are, but I will try to provide something where you get to throw out a low quiz grade or a couple low quiz grades, something, or give you an opportunity to replace a quiz grade at the end. So yes, I'll try to provide some opportunities to improve your grade that way. Balmaro.
Is it possible to take it after one test on the computer?
At the moment, I haven't considered something like that, where you would take a test in the computer and use that as a possibility. Let me reflect on that a little bit. If you have suggestions that way, I'm more than willing to discuss it. If you have some idea, that might be a possibility. At the moment, I hadn't thought in terms of that, but I'd like to have a little more time than just right now to think about it. So I'm hearing what both you and Dion are saying. Kim?
You shouldn't work on those tests yet. Without decisions made.
No, you can work on those tests. It's just that you aren't going to, at this moment, get any credit for them. You're certainly welcome to work on them. I just don't have it as part of the assignment, nor am I, at the moment, making a decision whether I would use the results. So as it's set up right now, you could repeat those tests. Now, if I did it as a situation where I did not want a repetition allowed, then I would say, okay, you have this time frame. It opens up, I can indicate in what I do how long you have for that test. And so I could put a time frame on it, and then you just do what you can in that time frame without being able to repeat. I would like to be able to talk a little bit more about that before I make a decision. But back to Dion's question. I think certainly I entertain the thought, and this is something that Sarah and I have discussed in terms of what she's doing, and that's the opportunity to replace a low quiz grade or do something so if you had a bad day, it doesn't sit there and mess you up. Now, anything else in 1-6 as far as the problems? James? The pyramid, I'm not going to do at the moment. I have some ideas about the pyramid for tomorrow, which is the tutorial. Okay, so like the Egyptians, we will take our time with the pyramids. New material. Chapter 2. Integers. Now, this material, for what we have done, is not particularly new. Now, what I'm going to share with you here in just a moment, let's see where I want to go with this. I've got to stop and think where I would have done it. It's in the orange book from the Math 10. And when we were working with what I think was, yes, I'm getting there. This was the simple closed curves. And we talked about that. And I just want to put a diagram from the past on the document cam. There it is, if you will, please, Jonathan. Now, that's from the unit on simple closed curves. And of course, what we said is that you have positives. Remember, this was your origin, your vertical axis, your horizontal axis. And we said if we go to the right, 1, 2, 3, and so on. And to the left, we said it was negative because it was on the left side of this 0 point. And above the origin, positive, below the origin, negative. So we referred to these numbers from 0, 1, 2, and 3 as whole numbers, or the counting numbers starting with 1. And we really didn't say too much about these other than it was clear what you were doing on the number line. Now, this whole set of numbers I have coming across here, because this can go to the left forever, to the right forever. So we think of those as integers. And so the word that we talk about is an integer, or just the set of integers as I go to the board. And the integers are positive and negative of the whole numbers. Now we create a new language in this process. So to that extent, 3 and negative 3, you know where to find them in the number line. But we consider them inverses of each other. So when I look at this diagram on the document cam again, this positive 3, we don't usually put a plus with it, but it's understood to be a positive number. And the negative 3 over here, it is telling you the direction you are relative to the origin. But we consider this negative 3 the inverse of the positive 3. And this gets back to Emily's question about the other two properties we had. Now, there's an interesting concept here. If I add a number and its inverse, so I add 3 and negative 3, the argument is I will get 0. So if you add a positive 3 and a negative 3, you're going to get 0. What we're really saying that for every positive integer, there is an additive inverse of that integer, so that when you add these two together, you'll get 0. We refer to this one as the additive inverse. The inverse for addition. So this is called the additive inverse, as opposed to the identity, which is what we have down here. So this is referred to as the additive identity, or the identity for addition. And this is the inverse for addition right here.
So the 3, not the negative.
They are additive inverses of each other. So the 3 and negative 3 are additive inverses of each other. And the 0 is the additive identity, because if I add 0 to anything, I get what I started with. Now, back to Emily's property. If A is my number, we're saying there's an additive inverse of A called minus A, so that when you add them together, you get 0. And that's the additive inverse property. So for every number A, there is a negative A, and if you add those two together, you'll get the identity for addition. So as I go back to my diagram, the idea that I have a 3 here, there's another number on the other side of the origin that's the same distance away, and we call it negative 3, and we name it the inverse of 3 with addition. Because if I add those two together, I get 0. Okay, so we come off there, Jonathan. And back to where I am. Thank you. Is there a question on that language? Okay, Dion.
Okay, so
Bless you.
when you're using the letters, right, how you said, like, you have the -3, or you have, let's say, how you written it on the board, 3 plus -3, it, as a then, it's an additive inverse, but only when it turns into the 0.
Yes, okay.
Zeros, it becomes an additive identity, right?
Yes, but the point, what Dion's saying, whenever I start with a number and I take the negative of that number, I have a number and its inverse. And when I get 0 at the end, I have the additive identity. But I'm going to take what you said because I don't have to start with a positive number. Now watch what I do next as I go to the board. Be careful. I'm going to start up here now with a -3. I want to add to that the additive inverse of -3. So that must give me, if I have a number and I add its inverse, I must get 0. I said I have a -3 plus the inverse of -3. So what does the inverse of -3 have to equal? This has to be 3. Because a -3 plus 3 is 0. So the negative of -3, which is the additive inverse of -3, has to be 3. No, I'm saying -3 plus 3 is 0. Michael.
Is that because a negative and a negative is positive?
Okay, this brings up the question of how you want to look at that negative of the negative of 3. At the moment, I'm looking at -3 as an integer. And I'm looking at the sign out in front of that as saying the additive inverse. So if I look back at my diagram, back to the document cam, then I'm saying I start with the -3, but the additive inverse of that is flip it back on the other side, so that has to be +3. So I'm flipping back and forth. If I start here, its inverse is here. If I start here, the inverse is there. How do I indicate that I want the additive inverse of -3? I use this language, which is this expression, before I answer questions. Now, Michael's saying I can treat that like a negative of a negative of 3. Yes, we could. There are a couple things I can do here. One, I can argue from a logic point of view. If I have no money, that's like -3. If I have no money, I'm back to having money. It's the double negative in language that we don't usually allow you to use. So if you're going out, you're not going in. If you're not out, then you're not in, which is you're in. This does not work well with language. But that's why you're not allowed the double negative in language, because it really means the positive. So if you say, I ain't got none, means you have some. Now that's extremely bad English. But nonetheless, it's used all the time. Okay? If you say, I don't have none, you have some. That's the double negative. That's logic. Okay? So we talk about negation and logic, predicate logic, and that is a philosophy course. Remember the no-see-um? Here goes. I'm going to go to a section we haven't had momentarily, but some of you have had enough that I think you're going to relate. We talk about multiplying positives and negatives together. Now we're getting to the idea of multiplication of signed numbers. And the rule will be, this is a kind of on the side, we don't know it yet, let's talk about it. If you take a negative times a negative, or a positive times a positive, you're going to find that the answer is positive. If we take a negative times a positive, or a positive times a negative, I'm referring to numbers here, so this is sort of sloppy language, the answer will be negative. Okay, so if the signs are different, we get a negative. If the signs are the same, we get a positive. Fair enough? So I could look first at this minus 3 as being like minus 1 times 3. Because I should get, the 3 is understood to be positive, then the 1 is negative. That product is going to be negative 3. That's the noceum 1. Let's look at this. This is like negative 1 times a negative 1 times 3. Well, the product of these two negative 1s is positive, and a positive 3 would be your answer. And that may help you in terms of this pattern in multiplication. Unfortunately, to establish this pattern, I really have to come back to this. Because the only way I can defend that the additive inverse of negative 3 is 3 is because I'm supposed to get 0 here. In essence, what I say is I know this is true. If this is true, and I got 0 from here, that means these two must say the same thing. Now, if it doesn't feel comfortable, that's okay for the moment, because I'm going to go further, and I'm going to use this as an analogy. I see the questions. I'll be with you in a moment. I don't know if you can remember when you learned to drive, but driving on McHenry in rush hour traffic was a little bit frightening. And if you got comfortable with that, you went out on the country roads, and then you went to the freeway. But there's nothing to prepare you for crossing the Bay Bridge and going into 4 or 5 lanes each way with traffic going back and forth. And you get comfortable with that, and then you go to the Santa Monica Freeway down in Los Angeles, and now you got the same thing, but they're doing 70 and 80, flying at you like mosquitoes. And you have the death grip in the wheel, and you're terrified, and you hope nobody hits you. And you don't dare slow down, they'll run over you. You do that for a few weeks, and pretty soon you're acting just like one of those other mosquitoes. Just as insane. Okay? Right now, this is feeling a little bit uncomfortable. If I take you through a few more freeways, this isn't going to seem so bad. So, before I go any further with very many more questions, I'll answer a few, and then I'm going to push a little bit further. First, Emily. It is the inverse of addition property or the additive inverse property. Your choice. Know them both. Inverse of addition or additive inverse. Dion.
Isn't another logical way of looking at it, like, remember that it's not an adding number? Because it's 0. And there you have said.
Let's come back to the diagram and see if I can put together what you're asking. So on the diagram, what I was saying was you can think of the minus 3 as being the inverse of the 3. I just flipped the other side. So if I'm here at minus 3 and I want its inverse, I know it has to be here. But how do I designate that I want the inverse of that minus 3? I have to come back and say it is minus the minus 3. Now, with that said, I went back to the diagram. Distance. The distance between minus 3 and 0 is the same as the distance from 0 to 3, correct?
Yeah.
So if I want to know how far any number is from the origin, I want its distance. Agreed?
Yeah.
So I need some language that will tell me about the distance. Okay? that brings me to this idea. The absolute value. It says how far from 0 is the number. So if I say, and I write vertical line for absolute values, so I'm making those big. They aren't usually drawn that big. So I want the absolute value of negative 3. How far is negative 3 from 0? It's 3. So the distance of negative 3 from 0 is just a positive number, 3. No direction, just distance. Now, small segue. And I'm trying to, remember, everything I talk about, I try to sort of lead to a future. If you were to take a physics course, like physics, chemistry, so if you're an engineering major, you have the mathematics, you have the physics courses, you have the chemistry courses, you have the drawing courses. If you're in a physics course, we talk about distance and direction. So the distance of 3 and the direction is to the left of 0 because that's the minus sign. We refer to those sometimes as vectors. So vectors involve distance and direction. Distance and direction, and we represent a vector with a little arrow. I don't want to go further than that for the moment. But the idea is distance and direction are separate. So if I take the absolute value of negative 3, I get 3. What is the absolute value of 3? It's also 3. Putting it another way, every time you get an absolute value, you get a positive number. Okay, I'm going to take you a little bit further now. You told me that the negative, the additive inverse of negative, well, you didn't tell me, you hardly agreed with me, but I told you that the additive inverse of the additive inverse of 3 is 3. So the negative of a negative 3 is 3, putting it in Michael's phrase, which is the way it's often talked about. What would this be? Good. This is the additive inverse of the absolute value of negative 3. The absolute value of negative 3 is 3. This is separate from that for the moment. So the absolute value of negative 3 is 3, but you wanted the additive inverse of that, so you get negative 3. You don't bring this minus sign through like the negative of the negative. So vertical lines, vertical bars, absolute value. Up here, slide just a smidge. Thank you. The parentheses here, I can bring that minus sign through, if you will, and think of it as a minus, which is the negative of the negative, which brings me to the positive. A little bit shaky. Any question before I... Okay, Bolmaro, you had a comment or question? Are we okay? Okay. Now, we can really mess up these expressions, trying to see if you know how to handle them. So I could do the following, just to mess with your head. I don't know if I want to mess with your head right here. Well, I'll do it down here, right after here. This is sort of my scratch work. What is the additive inverse of the additive inverse of the additive inverse of the additive inverse of 3? Well, I've heard two different answers, positive 3 and negative 3. They can't both be right. I'm still listening to the arguments going on and the indecision. I'm hearing more positives than I'm hearing negatives. The positives have it. Okay, let's back up from here, just that much. That's just negative 3. Now that first, the second one is the additive inverse of that, which we said brings us to 3. then that, okay, so you have the additive inverse of negative 3 is positive 3. The additive inverse of that is negative 3. And the additive inverse of that is positive. Hint, count the negative signs. Count the negative signs. Because if you, treat them like negative 1, so the noceums. Negative 1 times negative 1 times negative 1 times negative 1. If I come back, okay, I'm sliding over just a bit, that's like negative 1 times negative 1 times negative 1 times negative 1 times 3. Yeah, that's a mess. Let me make that so it's not quite that bad. There we go. Each one of these negatives is like a negative 1, correct? So I said if you take a negative times a negative, you get a positive. And this negative times a negative would be a positive. And the positive times a positive is a positive, hence positive 3.
So if it would have been
If you have an even number of negatives, positive. An odd number of negatives, negative. That's easier to remember. This is like taking negative 1 to the 4th power. That means 4 negative numbers multiplied together, and in pairs they become positive. Okay, I'm coming back center, Jonathan, so I have no idea where you are with cameras at the moment, but I'll tell you where I'm headed. And I'm going to go back to the book. This first part here on negatives and absolute value, to some extent, is a little bit discomforting, but it's the critical part of pre-algebra, learning how to work with negative numbers. Now, I've given you in the process today 2 rules that you really need to remember. And with camera 2, Jonathan, give me the 2 rules on the right side as you're looking at the board, the negative times the negative, the positive times the positive, and bring those in. So these 2 rules say that if you multiply like-signed numbers, you get positives. If you multiply different signed numbers, you get negatives. So the positive, we can come off there, we don't usually write the plus sign with the number, but it's understood. So if I look at your text and go to where we now are talking about, on page 95, just to put some things in context, that's exactly what we were looking at with the graph from Math 10. That's the set of integers. And we talk about that being the number line. Just a comment here. I made this comment in Math 10. It's very important I make it now. There are more numbers on that number line than those silly integers. There are fractions, right? There are decimals. And there's an extremely important statement we will make. For every point on the number line, I don't care what point it is, there is a related number. And for every number I give you in the real numbers, there is a point on the number line. It's reverse, not inverse. The reverse of that. So for every point, a number. For every number, a point. That's a tremendously important statement in mathematics. For the moment, we are isolating on integers. It's a very temporary situation. The additive inverse is in the bottom of 97. And this is a case where, notice, I use the language, and this Emily comes back to where we were talking about how it's spelled and called. The additive inverse, the bottom of 97, and we have the negative 5. And notice I didn't say minus 5. I said negative 5. Now you'll hear them used interchangeably. And the argument for minus is that we usually think of that in terms of subtraction as opposed to a negative number. But that brings up another wrinkle. Okay, We aren't there yet, but it needs to be said. So back on the right side where you were, Jonathan. Back, slide over here just for a moment. Right there. Now I said that's the general property for the inverse for addition. For every A, there is something called minus A, so that when I add them together, I get the identity 0. Fair enough? I've got two letters now, A and B. That's a subtraction problem, the way we've talked about it, correct? So we say A minus B. In algebra, we don't have to subtract. We trade in subtraction for addition. So instead of saying A minus B, I will simply say it is the same as adding the additive inverse of B to A. So I don't subtract. I take the additive inverse of B, called minus B, or negative B, and add that to A. And I add two signed numbers. Now, I don't want to go beyond that for the moment, but my point is, when I say minus, we really don't think much in terms of subtraction in algebra. I trade it off for an addition problem. And by the way, I don't think of division. I trade it off for multiplication with the reciprocal that Richie has shared with us in the past. So I trade off a reciprocal for a multiplication rather than divide. It is awfully hard to parse this out into little pieces and not try to put some of those pieces together, or it doesn't make sense. The difficulty is not doing so much that I blow you away, but still enough that I keep you with the kind of overall view of what we're doing and why. Okay, back center. The definition at the bottom of page 97. Additive inverses, two numbers whose sum is 0. Okay? Now, if you think about that for a moment, I have two numbers whose sum is 0. There's only one way I can do it. I'm going to have one positive and one's negative. So if I give you 7, its inverse has to be negative 7, because when you add those, you get 0.
What's the odd number?
Well, it could be an even number. 6 added to negative 6. That'll be 0. So the inverse just means you have a negative of the other. Absolute value on page 96. I want places where you can go back and read. Notice it's a given number's distance from 0 on the number line. So we refer to it as distance. Now, all absolute values have to come out positive. Let me give you a problem I saw in the book. Still up here for a moment. Here was the problem. And I didn't like the solution they gave. One, two, three, four. 1, 2, 3, 4. Can an absolute value be negative? I don't care how many negatives I've got in there, it will have to be 3. Because absolute value has to be positive. No, they just said, well, the additive inverse of, otherwise, you have the additive inverse. You take that additive inverse, that's positive. Take that additive inverse, it's negative. Take that additive inverse, it's positive. Take that additive inverse, you get negative. And then when you're all done, you take the absolute value. It's got to be positive. So why'd you go through all the additive inverses? Yes, as Richie says, the absolute value bar says you've got to have a positive at the end. Now, Marisol's saying, well, what if I put a minus out here? Okay, then it's negative 3. Enough. Back center. On page 96, the idea of inequality is given here. And this is a little bit awkward if you aren't careful. I'm in the middle of page 96. I have a negative 12 and a negative 7. So the question is, should I have a less than or a greater than? I'm not real impressed with the way this is done, which is talking about which one's closer to 0. Heavens no. Question. What does that less than symbol mean? No. No. What? Less than. What does less than mean on the number line? To the left of. So less than, left of. Is negative 12 to the left, back to the document again. Is negative 12 to the left of negative 7? Yes. I don't have to worry about distance. Coming off there. Greater than means to the right of. So you could say negative 7 is greater than negative 12. Negative 7 is to the right of negative 12. If you aren't careful and you think of magnitude, you look at the 12 and say, it's bigger. Yeah, but negative 7 is to the right of negative 12. So we say negative 7 is greater than negative 12. It's closer to 0, yes, but left or right. Just compare which side you're on. That's all there is going on. There's some neat little rules here. You can look at them on page 98 in the middle of the book in blue. The additive inverse of a positive is negative. The additive inverse of a negative is positive. The additive inverse of 0 is 0. 0 doesn't have any signs. So what do you have to add to 0? Coming off there, please. Thank you. What do you have to add to 0 to get 0? 0. So it's its own additive inverse. And it has no sign associated with it. Now, by sign, I mean positive or negative. There's an idea, and I think you have the thing called connections on 99 at the bottom of the page, nearly. Yep. It says the following. Thank you, Jonathan. Absolute value symbols are treated like parentheses. I'm not sure I buy that. Okay, I had this. I'm waiting. Bitte. I have negative 3 and I have a negative outside. I could bring the negative through, right? And it became positive. Now, a mathematician cringes at that statement, but you understand what I mean. Can I bring this minus through? It's like a brick wall. It's not treated the same as a parenthesis. I can't bring that negative through. I have to take the absolute value first and then take the negative. Now, to the extent I'm supposed to do what's inside the bars, inside the parentheses, yes. But if I think of bringing this through and this not, then no. Hold on. Back to center. There are a few problems intended to help you here. And the one I was talking about where I felt that the way the answer was given, and I get answers in this particular version which irritate the devil out of me. I haven't been able to get another version. But look at this 110. What do you know the answer is immediately?
Positive 17.
Okay, we just say 17, or if you wish, positive 17. Because, as Richie said, the absolute value has to be positive. And there's nothing else in there but these negatives and a 17. Now, I'll read you the solution. The absolute value of the additive inverse of negative 17. I'm on page 103. So again, this statement here, I think is missing the point. Yeah, you got the absolute value of the additive inverse of the additive inverse of the additive inverse of 17. But the absolute value has to be what?
17.
Positive. So it's 17. So try to keep it a little bit simpler. This one, 100. Don't you love that one? Now notice how you've got to match up the open parentheses and the closed parentheses. So if you put this into a computer, there have to be just as many opens on the left as there are closed on the right. And that's what they're referred to. Open, 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 close, 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 close. Now, how many negatives did you have? 1, 2, 3, 4. It's got to be a 42. Because you have the product of 4 negative 1s, the noceums. Does the noceum help? I don't know. I sort of like the idea of trading in the minus for a negative 1. We'll do that a lot later on. It's a nice way of pulling it together. I don't know how to read your eyes today. You're somewhere between rolling them back in your head and glaring at me. Let's go to another problem. Yes. Okay, 49. The greater than sign has to go there. Why? Minus 9 is to the right of negative 12 on the number line. Again, number 49 has to be greater than because minus 9 is to the right of. Negative 19 is to the left of negative 17. This one's a little bit easier for you. 20 is to the right of 16. And you are more inclined to say, yeah, and 20 is bigger. But saying bigger, coming off there, as opposed to which side you're on, is going to confuse the issue. The only other thing that's done in this book is to try to give you a practical sense of when we use negative numbers. If you're at my farm in Iowa and it's 10 below 0, you say the high for the day, negative 10. I love it when they start out. It's negative 9 and the high will be negative 1. You start at minus 9 and it'll be negative 1 at the high point of the day. You haven't broken 0 yet, and then you drop down again. Okay? My heating bill was a lot this month in Iowa. Amazing. And we keep it down to something like 45 or something to keep the house from freezing, but it's cold. It was built in 1900, so the insulation isn't. And if we look at, you climb a mountain, you're going to have a positive number. You go to Death Valley and you're below sea level and you get a negative number for your elevation. Okay? Anything else in here that you owe somebody $20, negative 20. Somebody gives you $5, positive 5. You pay off a debt of $5, negative a negative 5. No. Well, you have $5 more now than you did because you were in the hole 5 before. Just going on.
It's like they're saying,
Then you don't have the $5 that you paid the debt.
Yeah, but it's gone, so now you're $5 ahead.
it's like that saying they say,
Then you have nothing in your pocket.
it's not like that.
Talk to her
It's
outside.
like they're saying they have.
Okay, talk to her outside.
Hey, Dr. Pearl, you heard that saying? And you heard that saying, as long as I owe you money, you'll never be broke.
That's exactly the point. Dion's got it. As long as I owe you money, you'll never be broke. Okay, I like that. There are a lot of problems here, and I gave you 30 of them for homework, with the idea that with 30 of them, you have a lot of repetition. That or a lot of frustration. Either way you look at it. You need to spend the time on them, and I really would encourage you having the opportunity to maybe work together so you can argue with each other. Don't beat each other up. Do it with passion, but with civility. So passionate civility. So with that, for tomorrow, I'm going to close down. I'm not done, so give me a moment before you pack it up. Tomorrow is our tutorial. We meet here, if you didn't know, at 10 o'clock, as usual. we have a quiz tomorrow which will only cover up through 1/6 because you have not done the homework yet, and I want you to have time to finish the homework, so I won't do absolute value or negative numbers. So we are stuck with things like the fence problems and the formula problems and 1-5, I believe it was, so 2 sections, and I'll talk about the pyramid tomorrow in the tutorial. If you have conflicts and can't be here, then a reminder for Monday. And that reminder is you won't be able to do your homework then because you'll need to be coming in here between the 9 and 10 hour so you can take your quiz before we start the class. With that, Jonathan, as we go back to John Lennon and imagine...